Hey everyone, so welcome back to Project Pro YouTube channel, and today I have a very special video for all the aspiring data professionals and most important aspiring data engineers. And why I'm creating this video? Because when I was starting my career as a data engineer, I had to struggle a lot to figure out that what is the exact roadmap to become a top-notch data engineer, what kind of skill sets I need to work on. And this is the very common problem for all the aspiring data engineers who start their journey and they are completely lost, they are completely off track, what needs to be followed, what needs to be learned. And that is why this is a special video for you all. So I will give you a brief walkthrough that how this data engineering roadmap will look like for all the aspiring data engineers, what all things you need to cover in step-by-step way. So make sure to watch this video till the very end and make sure you are following this roadmap in the proper sequence as well. So first thing, in the data engineering space, obviously the programming languages, right? So in the programming languages, there are three things which are quite popular in the data engineering. First is the Python, Java, and Scala. So anyone who is coming from these three programming languages background, data engineering is definitely a right choice for you. And here, if you can see, I have marked it as a recommended Python. I have also been working on Python since very long time. I have worked with Java as well. I have worked with Scala as well. But why Python is recommended? Because it has become the language of data. If you go with Python, you will even have multiple doors open in the future. Let's say after 5 years, 6 years, you are not enjoying the data engineering domain, you can even take a move into data science where extensively those guys work on Python, or are you can even take a move to the data analyst background where again those guys are typically working on Python language, same the business analyst, BI engineering. So that is why it is recommended, and if you can work on it, that is pretty good. And based on use cases, if you get opportunity to work on Java and Scala, leverage that one as well. So programming language is definitely very much important to become a data engineer. Without this one, I think this is going to be the difficult as well, right? Because we need to write custom pipelines and programming is definitely needed. Next, if you go ahead with the Python, then definitely I would recommend 2-3 important Python libraries which you need to cover and which data engineers keep on using on day-to-day activities. First is pandas. It is basically to do the analysis on the structured data like row and columnar format, right? So pandas, numpy basically for mathematical operations, matplotlib for, you can say, just printing the dashboards, right? All these things. So data exploration libraries is very much important if you are going ahead with the Python. Third, a good understanding of operating system and scripting. So as a data engineer, most of the time we will be working on the server side as in like logging into the Linux machines or big servers where you need to just do a remote login onto a specific server, doing the SSH. And after that, everything is basically on command basis. You will be writing few commands, all those things will get executed, right? You will be moving files from here and there, doing the copies and even automating the stuff, right? So you have to have a really good idea about the operating system, how Linux, Unix commands actually works, how to do the shell scripting, write those script, right? So that you can automate the stuffs, and also how to schedule your jobs on the Linux based system, right? So that is something which you need to cover in the operating system and the scripting part. Next is the data structures and algorithm, and this is the most often asked doubt, you can say, from aspiring data engineers. How much DSA understanding is important to crack the data engineering interviews? And honestly speaking, based on my interview experiences so far for all top tech companies, top notch companies, what I have seen, DSA is something very important, right? Very important to crack your interviews. But the good thing is that the level of the coding questions is not gonna be that high. Like as you see in the software engineering interviews, for the data engineering interviews, this coding level is not going to be that high. The questions will be around the easy medium till medium, not beyond that. So anybody who's really good with the DSA fundamentals, problem solving and all these things, right, you can easily crack those rounds. And based on my experiences, these would be the very common topics which I would say to focus on, practice, like 10, 20, 30 questions for each topic, and you will get a good grip on the DSA part. So arrays, string, linked list, stack, queue, tree, graph, dynamic programming, searching, sorting. No need to deep dive too much into the graphs part like the Dijkstra, BSTs and all those things. No, same goes for the tree as well, right? Nothing like that is required. Just the basic, easy medium till medium level things. Now, the most important part, the database management system. And obviously, being a data professionals, our day-to-day activities will revolve around the databases. We need to dump the data into the databases. It can be transactional, it can be NoSQL. We need to pull the data from these databases as well. Time to time, we need to design the data warehouse, like we are trying to solve a problem statement, then how it should get stored in the database, how many tables will get created, how those table will be optimized, right? How that relationship will be created among the tables, how many dimension tables will be there. All these kind of typical database management related concepts will come into the picture. So the important topics you need to focus in the DBMS side, the typical understanding of RDBMS, how it works, when it should be used, its scalability part, schema types, diagram, acid property, transactions, concurrency control, deadlock, indexing, hashing, normalization forms, views, stored procedures, and all these things, typical, you can say, DBMS related concepts. Now, coming to the bread and butter for all the aspiring data professionals, or including the data engineers, data scientists, data analysts, any profile, SQL is something which is the bread and butter for all the data professionals. So you have to have like really good in-depth understanding of SQL, right? How to write the efficient query, effective queries, and deep dive into the advanced concepts of the SQL as well. So I have listed down all those things which you need to cover. Obviously, the basics of DDL, DML, DSL, how to write it, all type of joins, how to write the complex subqueries, nested subqueries, how to use the group by statement, case when statement, right? Common table expression, that means the with clause, different type of window functions, how to use it, and pivoting part. So all those things which are really important to explore within the SQL part. So make sure you complete it as well. Now, since these are something which are related to the fundamentals, right, to step into the data engineering, now we come to the core part, right, the core big data in-depth understanding. So first thing, very common and very important, to cover the basics and the basic terminologies. So you need to understand what is big data, 5 V's of big data, what is distributed computation, what is distributed storage, vertical horizontal scaling, commodity hardwares, how clusters work, what are different file formats like CSV, JSON, Avro, Parquet, ORC, different types of data like structured, unstructured, semi-structured. So just get that understanding clear, like the basic fundamentals, basic terminologies. Next, moving on to the data warehousing part. So this is something which is really important for all those folks who are at the mid senior level, because when you will go ahead for the interviews, the interviewers will majorly focus on the data warehouse designing part, that how you design the data warehouses, the effective and the optimized one, how you follow the best practices, the concepts of the data lake, data warehouse, data mart, fact tables, dimension tables, star schema, snowflake schema, right? All those things will come into picture. So from the design round interview perspective, this is something which is really important. So OLAP versus OLTP, again, dimension tables, fact, star schema, snowflake schema, warehouse designing questions. You need to focus on real world problem statements where you need to design a end-to-end data warehouse, slowly changing dimensions, their different types of SCDs. All those things needs to be covered in the data warehousing part. Now, once those concepts are built, next thing is something to focus on the big data frameworks, the actual thing data engineers keep on using in order to create the scalable and optimized data pipelines. So for that one, the basic and the most fundamental thing is good understanding of Hadoop and its ecosystem and all three its major component. So from the interview perspective, nobody is going to ask you to write a typical map reduce code, with respect to Hadoop, they completely focus on the architecture level understanding, the optimization related things, and how much you know about the Hadoop, in-depth understandings, right? So that is something which will be focused and more practical based scenarios. So make sure you have a good understanding of it, cover all three important components: HDFS, MapReduce, Yarn, and then comes the big data warehousing service, which is Apache Hive, right? So you need to cover at least all these things, major important things which I have mentioned here, like how to load the data for different file formats, how to create the internal tables, external tables, querying tables, right? Data is stored in HDFS, how to query that data, partitioning, bucketing, map side join, sorted merge join, writing user defined functions, serialization, deserialization in Hive. So these things are something which are really important. Next, the most demanding and the highly required skill sets for the data engineers is the Apache Spark. So Apache Spark is something which again you need to have a really good practical understanding, have some projects around it, and also in-depth understanding of it. So Apache Spark, within that, three more components are there, and I think these are good enough to start with. Get understanding of Spark Core, Spark SQL, and Spark Streaming. So Apache Spark also comes up with a Spark streaming, which is not a typical real time, but a near real time thing. But if you want to create a pure real time fault tolerant data pipeline, then I would definitely recommend Apache Flink. Like explore it and try to use it, and it would be really good to go ahead with the Apache Flink for the real time data processing. Then Apache Scoop, then Apache Niffy, Apache Flume. So these are some typical big data frameworks which are quite handy and most demanding in the data engineering skill sets. Next, coming to the schedulers and workflow managers. So now this is something which is the most important part. Let's say your pipeline is set up, it is ready to consume data from some source, then applying some transformation, and then dump the data into the downstream system. Everything is ready, but now you also need to automate these things, right? Like in how much frequency your pipeline will keep on executing. So for doing all those things, definitely we need some orchestration tools, workflow managers, or schedulers into the picture who will be automating our data pipelines. So for that, in the market, the most demanding thing is the Apache Airflow, then Azkaban, right? So this is something which you can cover, and I would definitely recommend, right, to have a good understanding of the orchestration tools. Now coming to the NoSQL databases, because this is also something which is very important in the big data system, because our traditional databases cannot hold that amount of humongous volume of the data and providing that level of efficiency and the fault tolerance, and obviously NoSQL databases will come into picture in that case. So the things which you can focus as a beginner in the NoSQL databases part, the HBase, the Cassandra, Elasticsearch, and the MongoDB part. Now coming to the messaging queues. So when it comes to design the real-time streaming pipelines, so apart from the processing engines, we need few messaging queues, right, which will keep on holding our messages for the time of consumption. We need a kind of queue where we can apply that pub sub model, like producers and consumer kind of thing. So definitely Apache Kafka is something which is widely used in terms of designing the real-time streaming data pipelines. So make sure you focus on this one as well. Get a good grip on Apache Kafka as well. Now the dashboarding part. So this is something which I wouldn't say the mandatory skill sets for the data engineers, but always a good to have thing, because when you will be doing the data governance part, let's say whatever pipeline you have created, in that case also you need to, right, have that kind of setup in your ecosystem so that continuously you are monitoring the health of your pipeline. And for that one, you need to create those kind of dashboards which are monitoring the health, the incoming events, the outgoing events, right? And anytime if something crashed or something is not going normally, then those kind of alerts can be raised. So this is one use case for the data engineers to have a good understanding of dashboarding. Apart from that, let's say you are working on a use case and based on the business needs, you have transformed the data and everything is available for the delivery part. But since the data analyst, business analyst, and the external audience will use this transformed data to create those dashboards and meaningful information, then as a data engineer, what you can do for improvement, just create those dashboards by your own, right? Have that understanding that whether you have applied the business rules correctly, because if something is missing, that will be captured on the dashboard because information will be wrong, right? So that is how this dashboarding information is also becomes very much important to have. And moving on to the last but not the least, and I would say the match made in the heaven, the, you can say, big data plus cloud services. So based on my experiences and the market cap which I have seen, and the kind of impact it has created in the IT industry, the AWS, right? This is something which is widely used in terms of the big data related things, software engineering, whatever it is. AWS definitely in demand. So same thing as a data engineer, if you are working on cloud agnostic data pipeline, then you should have a good understanding of any of the cloud provider like AWS, Azure, or GCP. Here I'm covering the things related to the AWS. So how it should be, the important services which you should definitely know in this space. First is the on-demand machines, like the typical servers of different configurations. For that, you can use AWS EC2. For access management, like who all can access particular service, what kind of authority they can have, we can use AWS IAM service. Then to store our credentials, let's say database related or any private key, public key related things, we can use AWS Secret Manager. For the distributed file storage, or you can say, or any persistent data storage, we can use AWS S3, which can store humongous amount of the data. And the transactional databases services, and including the serverless services, we can have AWS RDS. For the transactional database service, we can have AWS Athena as a serverless and highly scalable database service. Talking about the warehousing services, what we can say is the most effective data warehousing services in the cloud ecosystem, the AWS Redshift, highly optimized, very efficient in the performance, the runtime, and all those things. So very good to start with that. And if we talk about the NoSQL databases, AWS has come up with the AWS Dynamo, which is a key value based NoSQL database. Then serverless services like AWS Lambda. Coming to the ETL services, so for that one, AWS Glue is something which can help us to bring the data from different sources and then process it on the fly over the distributed cluster and then generate the transformed output. Then the scheduler part, we can have the AWS CloudWatch, and along with the scheduling, it can also be used for the monitoring part as well, and the cron based scheduling and the event driven based scheduling. Distributed data computation, so AWS EMR and AWS Glue are quite similar, but this is much more managed and it is more like the you can say simple cluster, right, or the Hadoop based cluster where you log in onto the edge node and you code all the things on the server side. But on Glue, things are quite managed, right? It has its own trigger. It gives you the feasibility of the crawler where you can crawl the data sets on the sources and on the destination, and that is how you can even go ahead with the incremental load and doing all those kind of transformations. Now the messaging queues part as well, the way Kafka works in the open source environment. Similarly, notification service like AWS SNS can be used and AWS SQS can also be used. Talking about the real-time data processing, here we can use the AWS Kinesis in order to create the data stream, which can be further consumed by any like CDC related system, which is capturing the event in the real time and processing it further. So this is something about the AWS within the big data ecosystem. And this is also the end of our extensive data engineering roadmap. So whatever I have listed down here, this is completely based on my experience, the practical experience which I have gained in the 5 years. And I can guarantee whosoever will follow this roadmap in this proper sequence, then within few months, approximately 3, 4, 5 months, you will be in a good condition to kickstart your data engineering journey. But one more thing which is really important and where Project Pro can definitely help you to get the practical hands-on. And for that one, you need the practical problem statements and end-to-end solved projects related to data and data engineering. And that is the major USP of our Project Pro platform, where you will be getting more than 270 plus completely end-to-end solved and tested projects, especially for the data science, data engineering, and big data. So make sure to check out the Project Pro platform so that you can also get the practical understandings and you can improve your portfolio. So that's what I had for you guys in this video. If you find it informative, then make sure to like this video. And if you have any query and any suggestion, feel free to put it in the comment section. And also don't forget to subscribe the Project Pro YouTube channel and press the notification icon.